The very first question I wanted to ask you was, can you please tell the audience about yourself and describe some of the projects you've worked on at SSAI?
Yeah, so thank you for the question. As mentioned briefly, my name is Kehan Yang, and I'm a research scientist with a background in cryosphere science, remote sensing, and machine learning AI. And my journey into cryosphere science, or more specifically snow science, began during graduate school when I was studying alpine lakes in the Tibetan Plateau for my master's research. And that work eventually led me to focus on mountain snowpacks in the Western United States for my PhD, which I completed at the University of Colorado Boulder in 2021. So my research is focused on estimating snowpack distribution by combining ground observations, remote sensing, AI machine learning, and physically based models. And what drew me to SSAI was the opportunity to work on this really interesting project. I'm working on the next generation global snow and ice product, or we call it SNP. And this work is funded by the US Air Force because accurate snow and ice information is very critical for national security, and from military logistics to like strategic planning in regions like remote mountains and Arctic regions. So this is a really important, snow and ice information is really important for them. But the problem is that it's incredibly challenging to get accurate measurements like snow depths or snow water equivalent from satellite data using traditional methods. And that's where AI and machine learning open exciting new opportunities. I've also been fortunate to contribute to some major NASA snow missions like SnowX, which is essentially NASA's massive field campaign to figure out opportunities to get more accurate measurement of snow characteristics in a variety of terrains and vegetation canopies. So we are combining like ground teams, airborne crafts, and also satellite across multiple winter seasons and in locations like Colorado, and I think there's Fairbanks, like Arctic regions, to explore the best approaches to measure snow from space. All of these efforts are intended to inform future snow mission, like snow satellite mission design. And so it's very exciting to really do snow research with SSAI and with NASA group.
Wow, that's very interesting to hear, Kohan. I really appreciate you highlighting your background and also some of the projects that you're currently working on. Kohan, my next question I wanted to ask you was, your research, like you mentioned, uses machine learning to improve how we measure global snow depth from satellites, which plays a huge role in tracking things like water availability and social ecological processes. How does this kind of innovation tie into SSAI's broader mission of using AI and data science to solve complex challenges across Earth systems?
Okay, this is a really good question. So I think built on what I've just described, my work on the snow and ice product, or SNP we call it, really showcase how SSAI is transitioning like Earth science through AI and data science. So, like measuring snow from space is very difficult. Like NASA doesn't actually have a dedicated satellite just for global snow observations. So for decades, we relied on piezo microwave sensors and used a very simple approach for snow depth retrieval. Basically taking like empirical relationships between snow depths and brightness temperatures that the satellite observes to get snow globally. It worked okay, but it had significant challenges and very, very high uncertainty. So with involving AI techniques, we now have the capacity to develop much more sophisticated algorithms that can extract better global snow depth information from the same satellite data. This exactly what motivated the SNP project I'm working on, and we are essentially teaching the machine to learn snow in ways the traditional methods could never do. So And what makes this work even more impactful is how it integrated into larger modeling systems. So our SNP data fed directly into NASA's Global Hydrological Information System, which is this incredible framework that combines satellite observations, ground measurements, and advanced modeling to do better predictions, like for the flood events predictions and seasonal to subseasonal stream flow forecasting, these kind of things. So if we have like more accurate snow depth information, we can provide more accurate upstream flow predictions. So that can be very impactful. And this AI-powered approach enhances this entire operational infrastructures that many government agencies depend on for their decision making. So it's perfect example of SSAI's philosophy or broad mission. So taking the most advanced AI and data science techniques available and apply them to solve critical Earth system challenges that have real world impact.
Kohan, I think that was very well said. And, definitely with all the advances that we've had, with technology now, especially with AI and machine learning, there's definitely more that we can do. So I really appreciate you highlighting some of SSAI's technical capabilities and how we're trying to solve problems in our communities, especially as it pertains to your work. Kohan, my next question I wanted to ask you was, accurate snow data can make a big difference, from predicting floods to managing water resources and preparing communities for extreme weather. Can you share how your work and SSAI's expertise in satellite data and modeling helps protect lives and support better decisions around the world?
Yeah, thank you for asking this. I think better snow data directly translates to better water management and forecasting, and I can provide some examples. So for water resources management, our improved snow measurements help utilities and agriculture managers plan like months in advance. In places like Western US, like Colorado, California, snow is literally stored water, so it's natural reservoir system that stores water in the winter months and gradually release water into summer when human and like natural like ecosystem water demand is high. So with more accurate snow depths or like generally snow information, water managers can better decide when to release water from reservoirs, when to restrict like storage, and when to prepare for drought conditions. So when we can accurately predict how much snow is in mountain watersheds and how fast it's melting, emergency managers can issue earlier warning for, like, for example, spring flooding. We've seen cases where just a few days of like early warning time allowed communities to evacuate safely to or like reinforce flood defenses. So another aspect is national security, which is also really, really important. So military operations in places like Afghanistan or Arctic or mountainous regions depend on accurate terrain information and like snow information for their mobility. So our global, like the GHI or the Global Hydro Information System provides ground conditions that can affect everything from like vehicle mobility to supply like routes. So when you're planning a mission, like in remote areas, knowing whether the ground is frozen soil or it's like a snow covered, how deep the snow is, can be very different between like success and failure. So or maybe like life and death maybe through our like partners with agencies like Air Force, we ensure our resources become operational reality. We train them to use these tools, and we also maintain the system like to run 24/7, and we also continually provide information based on their feedback. So I think the bottom line is every improvement we make in snow measurement accurately ripples out to like better decisions that protect lives, support economies, and also enhance security. And this real world impact is, I think that is what drives my passion for the work I've done every day.
Kohan, you brought up some excellent points there. So I definitely appreciate you giving an overview about how your work is impacting many different regions. Kohan, my final question I wanted to ask you was, and this is a fun question, just as a side note, but the question is, when most people think of snow, they think of snow days or skiing, not satellites and algorithms. What's something surprising you've learned about snow from space that most people would never guess?
Okay, it's a very interesting question. When I first started looking at snow from satellites, I thought it would be pretty straightforward, those white stuff on the ground, right? But I learned some absolutely fascinating things that completely changed how I see snow. So, do you want to guess what percentage of the world's population depends on snow melt for their water supply? Give a number, like
Um,
percentage.
Percentage. If I had to take a guess, maybe 40%.
40%, wow. It's actually about 1/6 of all people on Earth. It's roughly 17%. So which
Wow.
translates to about 1.3 billion people, and that's around 4 times the entire US population.
Wow.
This was one of my first realizations that snow is so much more than just skiing and snow days,
Mhm.
right? But here's what really blow my mind. So snow is one of the most powerful climate regulator on our planet. So like Earth's natural summer state. When snow covers the ground, it reflects about 90 to like 80 to 90 of sunlight back to the space. So it's acting like a giant mirror. But when that snow melts and exposes dark soil or vegetation, suddenly the same area absorbs 90 to 80% of sunlight instead. So it's just like a complete flip. And this
Mhm.
means losing just a small patch of snow cover is like removing a massive air conditioner unit from the planet. And that's why you're seeing these dramatic feedback loops in places like Greenland. As snow melts, it creates conditions for even more melting. And here's something that surprised even me as a scientist. So dust from the Sahara Desert can travel thousands of miles and land to the on the snowpack in Colorado, and resulting in like faster snow melt. So it's really opened my eyes to like how snow can connect everything and desert to mountains, local watershed to global climate patterns. And from space, you realize that snow isn't just water recreation, like snow days or ski. It's these incredible dynamic systems that helps regulate our entire planet's temperature while providing like water security for over 1 billion people. So it's really amazing to study snow as a scientist, and also I hope everybody can get fun playing with snow and for the like ski and the snow days.
Absolutely, Kohan. Well, I can definitely emphasize that you've made me, very excited, especially, for the upcoming winter, that's coming, and in
Yeah.
terms of, snow as well. I definitely want to do some continued further research on that. So, and I appreciate you like highlighting what percentage of the overall, population depends on snow. I was a little bit high there, but it was still something brand new that I even learned today as well. So, Kohan, like I said, I really appreciate you highlighting that there. And with that, Kolhan, again, I just wanted to thank you so much. You are truly a rock star who is really making an impact and a difference globally. And everybody around the world is going to continue to be fascinated about the great work that you and your team are currently doing. Please definitely keep us informed. Let us know about some continued advancements that come with your snow research. And we're very excited to highlight that, especially because winter's coming soon.
Yeah. Thank you, Jensen.